Okay, so again, making sure it's in standard form, set equal to 0, you identify the A, B, and C, and you literally plug them into your equation. Now what this is going to find for us is the zeros. Okay, those are the answers we're going to get. And we are going to get 2 of them because of the plus or minus symbol that we see. Now, sometimes the number under the radical, once we simplify this, will come out to be like the square root of 4. We'll take the square root of 4 to get 2, and then we might have to actually add and subtract to get 2 distinct answers. Sometimes our answer will be written like this. Now, they don't put parentheses in, but technically these are grouped underneath that big square root symbol. So you want to make sure that you perform all of these operations using exponents first, multiplication second, 4 times A times C, and then subtraction at the end using please excuse my dear Aunt Sally. Then the very last thing is to take the square root, which we may have to reduce the radical. And then it's all over 2A. So this is the most notorious song that will help you memorize this. One of my former students just came in and sang it the other day from memory.
My formula is negative B plus or minus the square root of B squared minus 4AC all over 2A.
Pop goes the weasel.
Quadratic formula is negative B plus or minus the square root of B squared minus 4AC all over 2A.
You have to memorize it. That's probably the most catchy way to memorize the formula, and I'll play it a couple more times later. But there are other formulas songs that I'll show you once we are working on some independent practice problems. But let's go ahead and do one together. So the first thing we want to do is get this in standard form, so I'm going to have to subtract 2 first. To get it set equal to 0. And then if you want, you can identify what A, B, and C are off to the side if you feel like you need to. So A would be 3, B would be a negative 5, and C would be a negative 2. And then on your homework tonight only, I would like you to write the formula on every single problem to help you memorize it. So we'll start by writing just the formula, which is negative B plus or minus the square root of B squared minus 4AC all over 2A. Okay, so that is the opposite of B, I should say. We sometimes say negative B, but it is the opposite. So if it is negative, it'll become positive. If it's positive, it becomes negative. Now we want to substitute in our values. So B was a negative 5, so if I'm taking the opposite, that would be a positive 5, plus or minus the square root. Now for negatives, you want to put parentheses around them. This would be parenthesis negative 5 squared minus 4, and I usually just put parentheses around every number I plug in, but that's a personal thing. So A, I would plug in a 3, and C, I'll plug in a negative 2. All over 2A. Obviously, if you plug in 2B in the bottom, you're going to get the wrong answer. So just take your time in plugging that stuff in. And then from here, it's literally the order of operations. So you're just doing your, please excuse my dear Aunt Sally. We are going to have to do everything under the radical first. So using the order of operations underneath that radical. And as I said, there is an imaginary set of like parentheses grouping that all together. So the first thing would be to do our exponents. Negative 5 squared is a positive 25. Now it's up to you how you want to do the multiplication. Some students will like to multiply all 3 things together. Like negative 4 times 3 is negative 12. Negative 12 times negative 2 would be a positive 24, and put plus 24 right now. That's personally how I do it, but if you prefer, you can do 2 at a time. So like negative 4 times negative 6, and then negative 4 times negative 6 will get me a positive 24. But you want to make sure that you're including this symbol whenever you multiply. So I am going to end up getting a positive 24 here. All over 2 times 3, which is 6. Last step then is to actually add those together. I'm at 49. Now this one is a perfect square, so we'll actually take the square root of 49, which is 7. If it were not a perfect square, we would reduce the radical if necessary. So now I have 5 plus or minus 7 over 6. Should I leave my final answer like that? Or could I actually find two distinct answers? Am I able to combine 5 and 7 together? Yeah. So you actually want to split this up and get two answers. You'll do 5 plus 7 over 6, and you'll do 5 minus 7 over 6, because they came out to be rational numbers. So we'll get 12/6, which will get me one of my answers is 2. And I will get -2/6, which I could reduce to be -1/3. My two answers are x equals 2 and -1/3. Now, because the answers came out to be like that, that means it was factorable to begin with. Had we have been given the option to choose to solve however we wanted to, it would have been factorable. Had we have done our guess and check method with 3x and x and then figuring out where 2 and 1 would go. Did say solve using the quadratic formula, so I wanted us to do that. All right, let's do one more together, and then I'm going to let you guys try one on your own on the back. Again, once I show this, it really ends up just becoming plugging in. We call it plug and chug. No problem. Okay, for this one, I actually would add 6x and add 7 because it's easier for you guys to work with positives than it is with negatives. You could subtract 2x squared if you wanted to, but I would probably add 6x and add 7. When you have positives, you're less likely to make a mistake. Identify what our a, b, and c are. So a is 2, b is a positive 6, and c is a positive 7. Had you have moved it over, they would all be negatives. You will get the same answer however you do it. Write out our formula. The quadratic formula is -b plus or minus the square root of b squared minus 4ac all over 2a. So the distance formula, sometimes it's easiest to memorize that little tune. And then just plug in. So this would be -6. The opposite of a positive is a negative. Again, I always just am over safe and I use parentheses everywhere. So this would be 6 squared minus 4 times 2 times 7 all over 2 times 2. And then you're literally just simplifying everything under the square root. Now, if you were to want to utilize your calculator, okay, you can. And you can type in everything that's under the square root without a square root. I mean, I want us to practice doing it by hand because you should be able to do it without the calculator. But if you wanted to use the calculator to assist you or to check your work, you can type in everything that's under the radical without a radical symbol. That's the easiest way to do this, to have the calculator assist you. Okay, so let's do it by hand first and then I'll check it with the calculator. So we would do our exponents first. Will get me 36. Now again, this is all multiplication. So -4 times 2 is -8. -8 times 7 would be -56, or a -56. You can do 2 at a time and then multiply the third one, but to save you work. Then we would need to subtract. We'll get -20 under my square root. Everything else kind of stays the same. And then let's double check that in the calculator. So I'll show you how to type it in. So you would literally type in what I've highlighted exactly as you see it. So 6 in parentheses squared minus 4 parentheses 2 parentheses 7. Oops. And you can get the -20. Okay. Most people, if they make a mistake, it's at that point. The under the square root part. So if you wanted to check it, that's how you would do it. You would never type in the actual square root because it'll give you a decimal. We don't want that. Now this one has to be reduced. Okay, we know that first of all the I should come out. So this would be -6 plus or minus I. 20 can break down into the square root of 4 and the square root of 5, which will get me 2 square roots of 5. Now, because it's all over 4, you may want to split it up because you're going to have to reduce the fractions, reducing each of them. So sometimes students prefer to split them up. when reducing. So negative 6/4 would reduce to be negative 3/2, plus or minus, and then 2/4, so I now have 2 over 4, would reduce to be 1/2, which would just be 1i squared of 5 over 2. And if you want to go back and put that as one fraction, you can, but if you have it all over 1, you do have to just make sure you reduce each number by 4, not just one of them. So this would be our final answer. We cannot add and subtract these because there's an imaginary complex part to it, and there's also an irrational number, which is our 5. All right, I'd like you guys to try 2b on the back. We'll skip over A. I'll tell you what the answers are in case you want more practice, but. And then we will do C because it's a word problem that we'll want to practice. And it kind of creates a little geometry. The longer leg of a right triangle is 1 unit longer than the shorter leg. The hypotenuse is 3 units long. What is the length of the shorter leg? So the first thing I would do is probably sketch a picture of a right triangle. I'm going to have to define variables to represent the sides. Now they do tell me the hypotenuse is 3 units long. Remember, the hypotenuse is the longest side, which is across from the right angle. Now they tell me that the longer leg is 1 unit longer than the shorter leg. So what kind of expressions could I write to represent the two legs? Hi?
The shorter leg 2x and then the longer leg x.
Good. Or you could do the longer leg is x and the shorter leg is x minus 1, but that's the easiest way to do it. One of them is x, the other one is x plus 1. Well, we know that the Pythagorean theorem is used to find the lengths of sides in a right triangle. A squared plus b squared equals c squared. Remember the legs, it doesn't matter which one you plug in where, but we would have x squared plus x plus 1 squared equals the hypotenuse squared. And then we're just going to solve for the two answers. We actually did one kind of similar to this before, and I did think it was the graphing calculator lesson where we did it using the graphing calculator. Remember, x squared is just x squared, but for this one we'd have to expand this first to be x plus 1 times the quantity x plus 1, and then we'd have to FOIL it. So get x squared plus 1x, which would be plus 2x, and then plus 1 equals 9. Combine our like terms. X squared plus x squared is 2x squared plus 2x plus 1 equals 9. And we would want to subtract 9 from both sides to get it in standard form. And then it doesn't say how you have to solve, so you literally could solve any of the ways that we've discovered. You could try and factor it. I'll tell you it's not factorable, so we won't waste our time, but you could try to factor it. You could use your graphing calculator, typing this into our y equals and doing second trace. Okay. Since this lesson's on the quadratic formula, let's just practice that one more time. Yes, you can. Did you hear what Clayton said? He said, can you reduce it and make the numbers smaller that you're plugging in? You can. You can take a GCF out if you want. So there's a 2 that we could factor out. Right? And then you could basically get rid of the 2. We see multiplication. The inverse of multiplying is to divide. And if you divide, you end up getting 0 divided by 2 is still 0. So if you'd like to reduce it first, then your A is 1, your B is 1, your C is negative 4, instead of having those bigger numbers, which you would have to reduce later. Excellent point. So now we have A is 1, B is 1, and C is negative 4. And if you didn't do that at the end, you are going to have to reduce the radical, which now we may not have to. I'll let you guys go ahead and finish that one. we're not gonna do just in case you want it, because you want extra practice. The answer to the closure ends up being, and this is one that has to get simplified a lot. -2 plus or minus 3 squared root of 5. Just hang on, let's try that. That one gets you some big numbers because you're throwing in a 41 for C. All right, the rest of the time is yours to work on the homework. I'm gonna play some math songs while you're working, so you guys can hate or enjoy them.